Hi, welcome all and everyone to the second on and offline lunch lecture of the year by TWD. I'm the chairman of KOers, so welcome Wilco.
Thank you.
Well, you will give a very interesting presentation about what TWD does, and after the presentation there is some time for everyone to ask some questions. And I hope you enjoy the lunch lecture and learn something new today. So if the sound is fixed, then take it away.
All right. Thank you very much. Indeed, there is room for questions afterwards, but I also want to keep it a bit interactive. So I'm going to also ask some questions during the lecture by means of a quiz. And also, if you have any urgent questions, you can always put them in the chat. For the ones that are in the lecture room, maybe you do have to save them to the end. And then you have to arrange if you walk towards the microphone. I guess that would be the best solution. But yeah, today we're going to talk about what we're doing at Temporary Works Design and engineering firm. The calendar, the agenda looks like this. Let's see if the clicker works. Yes. All right, so I'm going to start with a little introduction about myself. I will also guide you through an example project that I've actually been working on. I would also like to touch upon the design process that we are maintaining during our projects. There will be a quiz, like I said, about offshore wind. I will also touch upon the future of our engineering, and of course the potential of careers at TWD. In the Teams chat, you can actually raise your hand. So I would like to ask you guys, whoever is a bit familiar with the offshore wind, maybe you can do that right now.
Or in the lecture.
Yeah, in the lecture room, of course, as well. Does anyone know something about offshore wind? Because I know you are structural engineering and design, so I don't see a lot of hands, so that's good. I'm gonna actually talk about just that, so just sit back and relax, I would say. So yes, I am Wilco Vreugdeneel. I am currently working as a project engineer at TWD. I started 8 years ago at TWD as an intern, actually. So most of you probably also have done internship or still have to do that in your studies. This is when I started, and now I'm working full-time for Temporary Works Design. You see on the top left that I was on a site visit. This was about half a year ago on the innovation vessel. This was in Holland. And this vessel is installing currently some foundations for windmills, offshore windmill turbines. On the top right, it's also a similar kind of vessel that was in Belgium. On this vessel, there is actually structures on board that hold the components of the wind turbine rather than the foundation. But I'll touch upon that a bit more. Bottom right is our office in Rotterdam. It's almost in Schiedam. So then you just have a little bit of an outline on that. So what does Temporary Works Design do? I already showed you some pictures, but we develop methods and we design equipment for contractors that they can use to efficiently realize big construction projects. And of course, they want to do this safely and on time. So this is our task, our daily task, let's say. And the markets that we operate in are quite various. It is offshore wind, heavy civils, as you can see in the middle, in the top. Also offshore and gas, we're in salvage, decommissioning of, for example, old oil platforms. And we have a sister company that does motion compensation. You may have heard of Ampelman. We are also doing something similar as that, but then a little bit of a bigger scale, let's say. But most of all, we are in the offshore wind industry. So this is also what I will be talking about mostly. So I'm going to give you a bit of an overview of what I do as a project engineer on a daily basis. There are roughly about 7 phases here that can be distinguished. So Whenever a project is started, there's a lot of communication with the client in order to see what are the requirements and what are the desires of the client. Also, of course, we need to talk about planning and budget. So whenever that's sort of defined, we will go into the phase 2 where we do brainstorm sessions. That can either be with the client or internally. Usually that's a mix of both. Then we go towards the concept phase, sketching phase, let's say, where we come up with all kinds of concepts. We also do calculations to see the feasibility. We need to also check, does this actually, is this structure, for example, possible to put on the vessel? Is the vessel not too weak? Are there reinforcements required? We do, of course, a lot of calculations also with finite element methods, as you may know what it is. Yeah, and then of course in 3D we design the structures that eventually have to be also manufactured. So there's also quite a long phase, that's phase 6, about drafting and designing, which really means that from the 3D models with all the interfaces that we have, we need to also make production drawings. And then as a final stage, we offer also assistance in this fabrication. So we can actually go to the fabricator and help them out in case they have any questions on our designs. So this is more or less what we do on a daily basis. And I'm going to give you an example of a project. So here again, you see the same vessel as I was in front of in my introduction. This vessel is there to install the foundations of a windmill, mostly in the North Sea where it's not so deep. So this vessel can push itself up and then install those components. Usually those windmills, the foundations of them, they are existing of a very big pile. It's called a monopile in this case. Those are the ones with the rusty and white color. They are actually hammered into the ocean seabed, and then on top of it comes like a transition part, which is the yellow piece. And that's just the foundation of the windmill. After this, you still need to place the rest of your components. So that means you have to put up your windmill tower, also the main hub and the 3 blades, as you always see. So this vessel has a lot of equipment on board. One of those big pieces is the supports for these monopiles. There's a lot of requirements according to this, because those piles, they always come in different sizes. So there's different lengths, different diameters. So the client wants versatility here. So we need to think of solutions to actually accommodate for these changes. And that's what you can see in this design. So there's all kinds of interfaces that can rotate. Also, several mechanisms are there to slide back and forth. So these operations are relatively large, let's say, and also quite critical. So the client really wants like a robust solution here. The same goes for this upending bucket, which is used to lift the monopile upright. You maybe see that like in this slide, they are placed horizontally, but in order to put them into the seabed, you need to also lift those monopiles upright. So therefore you need a very big hinge. And this is also part of our designs. Then I would also like to focus a little bit on this item, but first I wanted to ask a question that some of you can maybe answer in the chat. What do you think a vessel like this costs approximately per day to operate, to have all these systems running and personnel? Can you maybe give a short indication of what you think a vessel like this costs? And I will give you the answer in a few seconds. Does somebody dare to guess? Maybe even in the audience?
The consensus is about 500,400,000.
500,400,000.
Yeah, okay. 500,000 or 400,000.
All right. Well, the cost of such a ship, I guess you guys are good at maybe like having some contingency in your estimates, but it's about 100,000 euros per day. So it was a bit off, but let's say the order of magnitude is still okay. But you can imagine with such costs, that the client also wants structures that are operated smoothly and that there are no major hiccups during the process, because that will always cost money. So this is something we always have to keep into our minds. The cleverer we design our structures and the better, the more suitable it is for our clients. So to explain a little bit on the design process, I'm going to show you a little bit on the tool we made to install. All right. This is the monopile gripper. It's a tool that is foldable. It's hanging on the outside of the vessel. And what it does is it actually guides the whole monopile during the hammering of the installation of the foundation. So here again, there's a lot of requirements that come from the client, and I will show you in a bit what we do in terms of designing process. You guys may have heard of the morphological charts. It's something that you probably have done in your bachelor. I at least have done it many times. We do it here too. So whenever there's a problem definition from the client, we go and look for how can we subdivide all of these problems. So this monopile has to be lowered, it has to be guided, but it also has to be placed into the right position. So there is a lot of different sub-problems that are tackled. And in order to come to the best solution, we always come up with several concepts. As you see on the top right, there's a various way of making a hinge, clamping, and also actuation in terms of cylinders. So that's something we discuss internally and then also share with the client in order to come to the best method. So here are a few examples of those concepts. As I said, this structure has to be foldable. You don't want to have this structure hanging outboard when you're sailing with your vessel. So there's a lot of ways to do this. And like I said, there needs to be actuation of the whole gripper ring in order to have a good placement of your foundation. So you can think of many concepts here. I'm not going to really dive into why each concept was better or not. But in the end, this is how the design process is then continued. So whenever we pick a concept, in this case, it is concept number 3. We start detailing it out in 3D. We do a lot of calculations. In the beginning, those calculations are less detailed. And the more you go through the design process, the more detailed these calculations will be. So you can see in the central image that we have at some point reached the detailed design. In this case, this can take up about 5 months, 6 months, but sometimes also longer, depending on the complexity. And then this part that I was telling you about is the drafting side of the design. So on the right, you see what kind of drafting is there, and this is of course just a part of it. But there's a lot of details here. It goes so much into detail that we even specify weld sizes and plate thicknesses and all the interfaces that are there. So it's quite an important job, let's say. I also have to check these drawings whenever they are made. So it's a very crucial job, let's say. And then in the end, of course, it's always super nice to see your structure being fabricated and also in operation. So we often go on site visits to check if everything is working according to our plan. And here you see, let's say, the end result. So this is in general quite a nice process. So when we look at the market that we are in, I already told you that we are in the offshore wind quite a lot, especially nowadays when the oil and gas is sort of decreasing a little bit. So that gives us a lot of chances. So our track record currently within Europe, where the most of the wind farms are, is 80%. So we are involved in over 80% of those wind farms in Europe. And of course, we're still expanding, and we also go towards the international market, let's say. I would like to invite you guys to go to the Kahoot site on your mobile phone. I think that's the easiest way to do this. There's password also indicated in the presentation. I will give you guys some time to log into this. Welcome to the Kahoot. So I think I'm aiming for 20 people approximately. All right, we've reached the 20 people. I think it's still possible to log in if you're a bit late. But let's start the quiz. Go to the first question. All right, so how many wind farms do you think there are worldwide? We just discussed that there's plenty of them in Europe. How many are there, do you think? Is it 21, 76, 53, or 102? All right, I see that most of the people have 76, which is the correct answer. Of course, this number is growing. So probably if you look in a few months, it's already a bit higher. But yeah, there's quite a number. And if you look online, you can find a lot of details about it. The biggest wind farm is currently in England. Yeah, it's enormous what kind of magnitudes in electricity there are reached. So good job for the first 9 ones. Let's go to the next question. Olaf is doing very well, I see. How many megawatts does the biggest offshore wind turbine generate, you think? Is this 12 megawatts, 10 megawatts, 8 megawatts, or 16 megawatts? See what you guys come up with. 19 answers. So one of you is not answering. Yes, 12 megawatts. Very good. I don't know if you guys already knew this or it was just a good estimation. But I would like to show you also a bit more information on this particular windmill. So this windmill is the General Electric Haliade X, and it's a 12 megawatt windmill. It's placed in Holland as well. It's the biggest windmill in Holland, and I believe also in Europe at the moment. It is placed on land, but it will also be placed in the ocean shortly. So we are working on projects with this massive windmill. The rotors are 220 meters in diameter, and if you compare it to other sizes, it's almost as big as the Eiffel Tower, so it's 260 meters high. So it's really massive what kind of developments there are currently, and it's actually growing and growing. At this moment, this is the largest wind turbine that is fabricated, but the stories are that they, of course, get bigger and bigger. So we have quite some challenges also at our company. Also, a nice side note here is that most of the windmills currently are placed in shallow water, like the North Sea. I don't know if you know a bit more about it, but the North Sea is about 40 meters deep, so it allows for easy installation, let's say, of those windmills on a single basis with one monopile. But if we go deeper and deeper, there will be different methods required in order to place those windmills safely. And you can also see there's even floating options. But of course, the same way as it goes with oil and gas, we first go for the easy route. That means that currently most of the windmills are installed in shallow waters. All right, so in this video, I'm going to show you exactly how this is done. It's an animation of Van Oort. This vessel has been operating for quite some years now. This structure that you now see sliding out is also designed by Temporary Works Design. It's again a monopile gripper, which has the flexibility of, well, folding in and out and also guiding the monopiles during installation. These vessels, as I said, they are positioned on the seabed with their own legs, so they are actually stationary, they don't float. That allows for easy installation. They have all the equipment on board in order to lift all these structures and to safely handle those big components. The crane is also of high capacity. I'm not sure, probably this capacity is around 2,000 tons, but also this number is increasing in the future vessels. So the monopile is now upended with some similar upending hinge, and then accordingly it's placed into the gripper. As you can imagine, it's the same with building a house where you have those big piles that are going into the soil. You need a big hammer for it. So that's also the same principle as here. Here you see that the gripper is closing its arms and that the rollers are activated to guide the whole monopile during the pile driving. And this is the hammer. So we're looking at a hammer that has a weight also of around 400 tons. And the hammering itself, depending on the soil, goes about 20 centimeters per hit. So you can imagine if you have to drive this monopile into the seabed that you require quite some time, because they usually go into the seabed around 20 meters, let's say, sometimes more, sometimes less. But yeah, so this is how it approximately works. Then, as I told you, these monopiles, the foundations of the windmills, they are quite big. Diameters range up to 8, 9, 10 meters, and they get even bigger and bigger. And on the right, you see our colleagues that were on a site visit placed in an Airbus, having almost kind of the same diameter. So the next question is actually about the weight of the monopile compared to the weight of an Airbus. And I'm going to give you some time to think about it and how you think these weights actually relate to each other. Yes, so we can go to the next question. I hope you're all ready. So how many times does an Airbus fit into a monopile in terms of weight? Is this 8 times? Do you think it's the same weight? Is it times 2? Or do you think it's times 5? "19 answers again. Right. So let's see. 5 times, yes. That's very good of you all. 10 people had it correctly. The weight of an Airbus, the empty weight, let's say, is around 250 tons, and the monopiles, they weigh around 1,250 tons, so it's around 5 times. Notice that those monopiles are getting bigger, so they are almost double the size in about 5 years from now. And weight. So this is quite challenging, let's say. That's why I also want to touch upon the future. We previously saw some vessels that were holding, let's say, 3 of those foundations on board. But what we now see in the future is that a lot of our clients, they request to handle even more components and bigger components. So what you then need? Well, you basically need new vessels, because the current vessels, they cannot hold it. This vessel of OHT, Offshore Heavy Transport, it's a Norwegian company. They are building this vessel at the moment, and it's supposed to hold around 9 of these monopiles, having a weight of around 2,000 tons. And you see also those yellow transition pieces again that they also want to install. But notice, this vessel does not have jacking possibility, so it's not actually standing on top of the seabed. So this is going to make the installation of these components way more complex, because you will be installing those components while the vessel is floating. That means that our structures that we design are also increased in complexity, because we need to look into motion compensation, and there's a lot of different force paths that you need to consider. So the future is bright, let's say, but it's also very challenging for us, because we are facing very big components, and it requires a different strategy, let's say. So that's it about the future. Then I would like to give a little bit more of an elaboration on what TWD is like. So I want to go to the next question. Congrats to Bart, which is currently leading. Yeah, the next question is about TWD as a company and the nationalities that work at TWD. How many different nationalities do you think there are at TWD? And I can already tell you we're quite an international company. So do you think it's 6, 22, 33, or 40? All right, again, most people have the right answer. So it's 33. It's quite a high number, let's say, and I'm going to show you also, yeah, how it's like. But first, the quiz has actually ended. So congratulations to Vincent, who became first, Bart second, and Mike third. Congratulations. So this is a short summary of our company. We have a very big melting pot, 33 internationalities. We see a lot of Dutch people, obviously, but the nationality rate between international and Dutch is about 50-50, so that's pretty nice. The average age is 30, which is relatively low because we're quite a young company. I believe 13 years at the moment. And you see that we have quite some Greek people and British people, and that is because we have some smaller offices also in London and Athens. So this is also a nice opportunity to sometimes, visit our other offices, let's say, and help out there. But in general, we have more than 200 employees, and it's still increasing because, the offshore wind industry is just booming. So there's a lot of opportunities. Here you see some good old photos of our company trips and events. I see some people laughing, and I don't know if it's because you all know that Corona is, of course, jeopardizing this a little bit. But we have a lot of females also in our company, so they do events together as well. We do sport activities, and in the top right you see that we also have Dress Like Your Boss Day, because our boss tends to dress the same way every day, so we decided to do the same thing. We go to fairs together, harbor runs, and of course we have like company trips to several places, sometimes even outside of Holland. So it's very nice, young, dynamic company, and lots of diverse people. So in short, we are a very young and dynamic company at Temporary Works Design. We are in a big variety of sector. We are also in an ever-growing market. There's a mixed duration of projects. Some take a year, some take 2 months. And we have our main office in Rotterdam and some smaller offices in London and Athens. And as I keep repeating, there's a lot of opportunities. The company is growing and the market is also growing. So the future is definitely bright. So as a final sort of advertisement, careers are possible. Even in this time, we are hiring people. So definitely stay in touch. I'm going to send you some links as well in the chat. I also would like to ask you guys to fill out a short survey on this presentation to see if we can improve or what you liked and what not. But yeah, there's plenty of open applications. So if you want to stay up to date, just go to our LinkedIn page or contact us through email or by phone. If you are just interested in some pictures and stories, you can also go to Instagram. And as I said, if you have some feedback, please fill out the survey and I will just send you those links in the chat. I'm gonna do that right now, and in the meantime, if you guys have any questions at the moment, please let me know in the chat or walk up to the mic in the lecture room, and then we'll answer those. Yes. I don't see any questions on the chat, so I believe all the people at home, they all understood.
Does anybody here have a question? Absolutely nobody.
Yeah, maybe some questions related to your own studies and things you always wondered. Let's say I always found it very nice during my internship and work alongside my studies that the actual, like formulas and all the stuff, the theory you learn at university can actually be applied in a practical sense, and that's very fulfilling. But I don't know if you have any like specific questions regarding your studies and how it can relate to our company.
I don't think anybody here has a question.
Okay. Well, I hope you all liked it.
Yeah, I'm sure we did. It was very interesting.
All right,
So yeah, I'd like to thank you again for our interesting lecture, and I hope to do this again.
Yes, no worries. Thank you all for your attention. And like I said, if you have any questions or further interest, just contact us and yeah, we'll be in touch.
Okay, thank you.
All right, have a good day. Bye-bye.